Down for my 70th birthday and got myself a pair of MTH PAs and got the sound put in by a professional instead of doing it myself. And I got the deep sound PA sound, so
these are your little babies, as you say.
They're my latest babies, but I love all Alcos, as you can tell. That was another driver for this Adirondack branch thing we forgot to mention it, the Alco sound. Yeah, so this is these PAs are leaving at 3 o'clock with the tourist train to Saratoga. So the cars are in the yard, and nothing's happening with those for another 3 scale hours.
Okay. The traditional way to portray this in a visual format is via string diagram, and a string diagram really takes the material that Michel has developed and puts it in a graphical format so we can all see it a little bit more easily. And Michel, you have here your string diagram, and maybe you could describe how this was created and how you use it.
Okay, number one, I have to say right off the bat that this is a worksheet program Excel. Okay, it's a chart that's derived using the Excel spreadsheet.
In other words, the formulas, everything that's been worked up to this point is now used as a basis for this.
That's right. Actually, what the program tells me, it tells me, okay, you want to build a chart, and anybody it could be any worksheet program, but the program will ask me questions and say, okay, what's your X and what's your Y? So the X is usually the distance between the miles between each location.
Okay, this is the scale miles?
The scale miles, yeah, okay. And this is the times. The times show like this because I compressed it to fit this sheet of paper, but on the computer, it's all like 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock. This is my
and this is the fast time.
This is the fast time, okay? This is my 12 hours we're talking about, plus a little bit, you know. 1800, I went to 20, 8 o'clock just in case to give it some space, otherwise it gets really compressed, okay? And on the other side, you've got the legend of the train numbers, okay? So what you do, actually, the computer is fantastic because you go, we'll take our train there, where is it? Like I'm looking, sorry, I won't like, NL102, Tahoe, Saratoga, remember? This is our train that we followed all along the process here. It goes from the mine to Saratoga, so here's our train on the graph. Okay, so this is the first one that went down, okay? Like nothing else was there, okay? And the first plot was, go select this. I selected this. The chart walks you through it. It's like really easy. You pick this with your mouse, and you follow the the chart formulas, and you end up with this graph right there. Now the magic of this is, once I've got all these, all the columns picked out, all the trains on the side, then if I want to make a change, okay, all I have to do is change the time, the start time. I can put like 1700 hours, I can put 1500 hours.
So for example, Michel, if you decided that you wanted to move this particular train, and maybe you wanted to, you know that it won't fit in here.
Yeah, but it could fit in here.
So if you wanted to move it into one of these, into this open space here,
that's right,
you could, in a sense, try it by changing the start time, and the graph would be rebuilt.
The graph would be redone right away. And the whole column here would be redone at the same time. That's the beauty of it. So I would put 1300 here, and then vroom, my schedule is redone, and the graph is moved over here. Okay.
Now let's supposing that you wanted to move this train. We won't question why, but let's just say you did want to move this train for some reason, and you wanted to move it, say, back in here against one of these trains. Could you show us how a meet is represented? Say it was going to meet one of these trains along the way. Could you show us how that's done?
Okay, well here it's done. You see, like there's these two trains. This train is a passenger train. This is the tourist train. Leaves Saratoga Adirondack Junction at he's at 1500, okay, hours, and meets the train from North Creek, the freight from North Creek, is scheduled to meet it at Thurman Junction, okay?
So it's where the lines cross.
Yes, and there's a siding there, okay? So the dispatcher gives a clearance, you know, this guy's got priority because he's on timetable, so he gets the main. This guy is extra, really, coming back, okay, from switching at North Creek. He's a way freight, basically. And so he left work, so he would take the siding, okay? So whichever one gets there first, you know, if the passenger train is always going to get the main, and when this guy gets his orders from the dispatcher, he's going to call in the dispatcher say, okay, you're clear to Thurman Junction in the siding. So this guy would go into the siding and meet the train there. They could have, depending on the length, they could have a running meet. In this case here, that's what I would like to happen, you know, like the trains meet together in the siding, one going and the other one going, and they clear and they go.
Okay. From a mechanical point of view, though, where the lines cross is where the trains meet. And if you happen to move, say you moved this train, we were talking about moving this train to another space, say you moved this train and you moved it somewhere and it crossed the line of another train, but it crossed it at a point where there was no station, what would you do?
Well, now this is where the graph becomes really, I'd have to move it. I'd have to move it where it can meet. Okay, for example, if I wanted to move it here, let's say around here somewhere, let's say I would move it to leave around 1330 or something, okay, then he would most likely, because of the curve, let's say 1400, okay, he would most likely come right into North Creek when this guy is ready to go. This other train, you would have to meet this train somewhere, I don't know where it would, okay, this is the other one from Sanford Lake that's coming. He's switching here, see the straight line? That's his like 1 hour switching that he has to do. So now I've got two tracks busy in there, eh? Like there's a siding, I know there's a siding in North Creek, and this baby would come here and meddle the whole game. So one of them would have to clear the main. Okay, the main would have to, because this guy's got 20 cars, okay, and he's got, even though he's not on the time, if he comes before and can be running before the passenger train arriving, fine. If not, he has to wait now. So I would have two trains waiting in North Creek for the passenger to clear.
So this really is part of the management.
Lot of decision. Then I'd have to play with the departure time here. Maybe it's 2:15, maybe it's 2:30, maybe it's 1:45 that he has to leave, you know.
Okay. So this is really has to do with the management of the movement of the trains on the railroad.
Exactly.
And this is a tool that allows you to more easily see, we'll put it that way, more easily see where there's potential conflicts.
Yes. In fact, this train was moved to 1600 hours for another reason as well. It used to leave around 1400, okay? And it was just going by or just in time. You know? What happens is that this train is also the what you call the main train of Tahouse. And the guy that, the conductor that runs this train becomes the yard master at Tahouse when he gets there in the morning. See, when he gets there in the morning, he's got the whole management of the yard for the day, because he's the king train, if you want, you know, like the master train that goes there. So this coal train that comes in the middle of the day, you know, has to be managed by a yard master, you know, in actual fact, a real train, eh? So this guy being the yard master while he's in Tahouse would prefer managing this train and leaving after this guy has done his work and left. So this guy, the coal extra, I run the coal extra, gets into Tahouse. The conductor for the NL202 manages the unloading of this train, ships the train out, if you want, at whatever time there that says. I got the extra. It comes in at 1347, extra freight coal loads, extra freight coal empty, 1545. Okay, so 15 minutes before he lets this guy go, and then he can go after that. Okay, so this is the way. This is a true management situation here. Why do I do it this way? Because I don't want anybody roaming into the yard in the national land not knowing exactly what they're doing. So I prefer having a yard master that knows the management of the operation of the yard in the house, because extras are usually given to guest operators or younger operators, if you want, the operators that haven't had like a major training on the railroad. Okay, so if I get a guest for an evening, I give him the coal train. It's a fun train. It's got the engines you don't like, but we won't get into that. He doesn't like sharks.
You just got into it.
Yeah, I know. I just like to rib him a bit. But so this way I've got somebody managing the yard while this whole thing happens, and if a guest feels more at ease because he's got somebody guiding him as to what to do. So this is another side of operations that you have to take into account.
I think we should emphasize again that this graph is really just a visual of this.
Oh, absolutely.
That for those people who are really good with a mass of numbers, I don't need the chart. But the vast majority of us would rather look at the chart and see the results of moving trains and scheduling trains. That's much easier to work with for most of us than this this graph of numbers.
Yes, because once we've resolved this, then we can go back to the prototype thing and publish the timetable that's going to be used for the management, okay, of the day-to-day operation of the railroad, which becomes this one here, which would be published in the actual timetable.
The employee timetable.
Employee timetable. And it doesn't show the coal train. You can see here, you know, like the coal train's nowhere there because he's an extra. So some nights you can run, some nights you can, but I know, and the dispatcher knows that he's got the room to run it.
In essence, right? The traffic department would look at this, and then the operating department looks at this one.
Exactly. Okay. And the operators are generally oblivious to that.
Yes.
You know, the only operators that care about this are these operators here, the ones that run the passenger trains, because they have to leave the stations and on time, and preferably get to their stations on time as well, as they have passengers, actual people to carry. So
if we relate this to different eras, and keeping in mind that you're operating in an era of track warrants and occupancy control, as opposed to, say, the earlier steam era.
Oh, yeah, like that.
In an earlier era, this full table may have been given to all the operators, and they would care about all of these numbers.
All of these. There would be no business in steam days about this time show conveys no timetable authority. There's none of that business.
But in the modern era and the era that you model,
it's more flexible.
The dispatcher is concerned with this, but the operator is less concerned unless he's got a passenger train.
Yeah, this is where the occupancy control system comes in. They have to call to get a track warrant.
Okay. Now let's take one more simple example. Supposing that we know that the Delaware and Hudson is really an extension of the Canadian Pacific down to the U.S. And let's just take an example where we said the Canadian Pacific decided that with the paper mills in Northern Ontario that it would get an additional train every day of paper from Northern Ontario, and it would be routed through Montreal, and it would go south on the Delaware and Hudson. And they asked you, now you've got the Adirondack branch here as opposed to the full Delaware and Hudson, but let's just assume for a minute that there would be an extra train across your railroad. How would you incorporate that in using these tools?
Okay. In my case, what would happen is that they would say, okay, we want to ship a different type of paper to a printer somewhere, you know, and I don't have a printer, but let's say Warrensburg has a printer. Then that would mean that the train would drop, that Canadian Pacific train would drop cars at Saratoga or Whitehall on the main, and then there would be an extra train, an extra freight SC Saratoga Champlain Division train, SC 7, let's say, and then I would have to plug it in somewhere. Like,
Okay, and say that you had this graph, where would you look to plug it in terms of fitting it on the railroad, the crew that you have, and so on?
I know that the Corinth operator, which were the Warrensburg operators, Warrensburg is free at these times. Between, say after this is the Warrensburg switching in the morning. Okay, that's the North Creek train that switches Warrensburg. So after this, I can incorporate a train. Okay, so I could, let's say I have a train at 10:30, 11 o'clock. Okay, and then that train would go to Warrensburg and do the switching, and then carry on to North Creek because it's a trailing siding. He has to go turn in North Creek, so he would have to embarrass the North Creek operator, which is like switching right here. Eh? So you see he's doing the switching, so in reverse, and then come back around, you know, between, preferably before the passenger train leaves, like 1400. That's feasible. It's feasible. So, I would have to give him an hour here to do the moves, and then maybe 30 minutes there to, but I would have to, okay, then go back to the timetable, you know, that we had here. Where was it? Hang on a minute. To this baby, the worksheet, okay, and go back to the worksheet and create a new column, okay, going northward and southward. Incorporate a new column here. Once you've got all your formulas done, it's easy. You just copy the formula. I would like copy the formula from the North Creek Saratoga train, for example, and which already has all the ingredients of a local freight, goes to North Creek. So I would repeat this baby here. If you want, I would just copy all the information that's in that column, put it in a new column, and then add it on here.
Right. But the string diagram at the outset allows you to see.
Then I'd see exactly what happens, because now I'm assuming I can do this. We're all talking about assumptions. I would have to create the actual number and column, and then it would appear here both ways, and then we'd have an extra train.
Okay. So out of all this, Michel has really given us a description of how a timetable can physically be prepared, and also how it can be used to manage the railroad.
Yeah, it's a great tool. It's a fantastic tool.
The real railroads have published over time employee timetables, and examples of these are fairly readily available at swap meets and so on. For those people who pick a specific prototype, it's useful to pick up an employee timetable for your favorite railroad from the era that you're modeling in, and just to get a sense of what's of how they operated. It's a very good research tool. The corollary is that model railroads also can produce an employee timetable. It has the benefit of maybe looking like making the railroad look like a real railroad, but it also has a benefit for the operators and the dispatcher. The timetable that we've talked about so far, Michel has prepared it for his Delaware and Hudson. It can be incorporated into an employee timetable. In steam days, the whole of the timetable probably would have been used, excepting for extras, and it would have formed the basis for timetable and train order operation. In more modern times, perhaps only the passenger trains would be shown, but in any case, the material is there to prepare an employee timetable, and Michel has done just that. And Michel, you have an example here. Tell us about what you've done.
What I've done is I've incorporated in this document here things such as simplified rules to operate the model railroad, general instructions, you know, as to what you can do, the brakes, take the brakes off when you leave, and so and here it's more like conceptually make the operator slow down the whole operation. So in other words, you don't leave with a train with the brakes on. So give yourself time to leave by counting the cars on your train, by using the 1000 number, 1001, 1002, and that is releasing the brakes and making sure that all the hand brakes are off, and then you get your release from the dispatcher to leave the station where you are, you know, like if you've just finished switching. Or so these are little things are explained in simplified rules, and also footnotes of the timetable that provide instructions for the operators at specific locations. You know, like you switch this, for example, on that train, the cars for location number 60, if you want, or this such and such a customer name, should be at the front of the train, and cars for this other location should be at the end of the train, because when you're going to the next town, you have to drop this car first. Okay, so like you write the footnote so that this way you don't take 3 hours to do your switching at the next station. Right? You know, you keep the timetable if you want. You know, you keep time. Little things like that. Also, some informational material for newcomers. A map of your operating area, where the Adirondack branch, where it's located, the geography, a schematic of the track plan. I noticed a nice typo there. I must have been late at night when I typed that one. And any other information that will ensure the operation of the model railroad, you know, just like a real railroad. And like you said, you can go to the prototype, which actually I do have a prototypical timetable of the Adirondack branch, and I picked out most of the rules from the actual timetable as to which type of locomotives can be used on the branch and so on, you know.
And I'd add my footnote, no sharks.
You didn't go there very often, actually.
Okay. This is a well-powered train to make it up the road.
Oh, yeah, exactly. You see, these are 1800 horsepower each, so it gives enough power to go up the hill. And more importantly, come down, you know, with the dynamics, and, you know.
Okay, now we're going to enter this area here, if you recall the track plan. We're going to enter the area of the dog bone.
Yes.
And this is where we're...
As soon as we leave milepost 19 there, you know, you can notice that there's a whistle post. There's a milepost 19 here.